Welcome back to the second episode of this 5-part series. Last time we built a machine learning model that learned from numbers. Today we'll ask a different question. What happens if the data isn't numbers, but language? We'll build a tiny language model from scratch and teach it to predict the next word in a sentence. My goal isn't to recreate ChatGPT on a laptop. It's to understand the underlying ideas so that by the end of the series we can make better judgment about what modern AI systems are actually doing. We will begin exactly as we did in a previous episode by creating a simple application. This gives us a place where we'll eventually use our language model. At the moment though, the application is simply a user interface. Just like last time, we'll first build the application and only then teach it how to perform a new task. Let's first install the dependencies and start the application. Everything is now running locally, of course. At this stage, however, the application doesn't contain a trained language model. That's intentional because we'll build that ourselves in the next steps. Here is the application. Notice that it already displays the training examples we'll eventually use. But if I try to predict the next word, the application tells us that no language model is available yet. Just like in the previous episode, the interface exists before the intelligence behind it does as well. This tiny dataset is what our model will learn from. Unlike ChatGPT, which is trained on enormous amounts of text, we'll use just a handful of carefully chosen examples. Notice that the word jam, for example, appears in different contexts. The model isn't given definitions. Instead, it learns statistical relationships between neighboring words by observing many examples. Now it's time to build the language model itself. I will ask Codex to generate the training code, create the model, and connect it to our application. As before, I'll fast forward through the code generation so we can focus on understanding what has been built rather than watching it appear. This file is responsible for training the language model. It loads the dataset, converts the examples into something the model can learn from, repeatedly predicts the next token, and gradually improves those predictions during training. Finally, it saves the trained model so it can be reused without repeating the entire training process every single time. This file contains the trained model itself. Just as we saw with linear regression in the previous episode, training ultimately produces numbers rather than words. Those numbers represent everything the model has learned from the dataset. They don't resemble sentences to us, but they are exactly what allows the model to generate predictions later on. Now the complete system comes together. The application loads the trained language model and predicts the next word based on the context it has seen before. This tiny model doesn't understand language the way people do, nor is it comparable to ChatGPT in capability. But at a high level, it's performing the same kind of task, predicting what comes next from patterns it learned during training. Today we've built a tiny language model from scratch. More importantly, we've seen that at a high level, modern language models are trained to recognize statistical patterns in language and use those patterns to predict what comes next. Of course, systems like ChatGPT are vastly larger, trained on far more data and capable of much richer behavior. But understanding this smaller example gives us a much stronger foundation for understanding the bigger ones as well. The question now becomes, if powerful language models already exist, should we really be building our own? In the next episode, we'll explore why in most real-world applications the answer is no. Thank you for watching.